Welcome friends. Today we are going to solve a trigonometric equation. As you people can see, I have already written the equation. This may seem a little bit of tough, but it's easy. Give yourself a try and then come back to see the solution. Okay, let's begin to solve this equation. See, there is a part of sine part and there is a part of cos. So let's just mix it up. So we can write it as like this. Right, we are just exchanging the sides. Now it's simple, we can adjust it and so on. So if we adjust it, there is, we are left with simply say right. And what about this part? We can simply factorize it, but till now let's it be the same. So this is it. Now if we do some factorization jobs, then it factors into like this: cos x minus sin x and cos square x plus cos x sin x plus sin square x, right? Yeah, it is simple, like a cube minus b cube formula. It's that simple. And what will be the right hand part? The right hand part will simply be like mm, this is a part and the bigger part will be something like this. And we are quite sure with this part because this is from the binomial theorem, right? This follows from the binomial theorem, typical binomial theorem for two variables. Like, see, I have written many things, so now cos 6, cos 5, cos 4, cos cube, cos square, cos 0. Okay, now there is one term left, then that term is sine to the power 6x, right? Okay, if you people have forgotten this, so let me make a quite easy note for you people that it follows something like this: x minus y, and then it is something x to the power n, xn minus 1 y plus dot 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 dot, and this continues until it becomes something like x y n minus 1 plus yn. Yeah, we just apply this simple formula. Now see, two cases arise. And the two cases are, if cos x minus sin x is non-zero, then we can eliminate these two things. But if cos x minus sin x is 0, then the whole things are 0, so we can't cancel it out. So we have to make two cases of this problem now. The first case will be the say case 1, and in this case we have cos x minus sin x equals to 0. It equals to 0, then what are the solutions? The solutions are simple: pi by 4 and pi plus pi by 4, and it simply goes on, right? This is the first case, and there is this kind of solutions. But in the second case, we can assume that this thing cos x minus sin x, this thing will never be 0, as this thing is not equals to 0, so we can cancel it out, right? If we cancel it out, what will be the left over portion? See, cos square x plus sin square x, it becomes 1, so we are left with 1 plus cos x sin x, and this whole thing, right? So let's make it simple. It like simply 1 plus cos x sin x divided by cos cube x sin cube x, and those all things say p, and here p stands for this whole part, cos cube, cos to the power 6x plus dot 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 up to sin to the power 6x, this whole part. Now we have to solve this part. It's quite tough if you don't substitute anything, so let's just substitute and make this problem a quite easy thing. Let that sin x cos x, this is t, okay, this thing is t, and then write this thing in terms of t. So we might have to find some way to write this whole bigger thing in terms of t. Let's just try. If we write this thing, it is simple, right? 1 plus t, and it is t cube. But what about this thing, this large thing? See, there is cos to the power 6x plus sin to the power 6x, so we can make them separate. So at first we separate them, and then we can do some more things, say like we can take commons cos x sin x, and this thing and this thing will result something more, like if we take common cos x sin x, they will simply result as cos to the power 4x plus sin to the power 4x. And now there is a term called cos cube x sin cube x, right? And the leftover terms are this term and this term. So what we can do now, we can take common cos square x sin square x. If we take common cos square x and sin square x, we can see that here cos square x plus sin square x, and we all know that cos square x plus sin square x is 1. So let me just write it for you like this. Okay, see, we have figured out the whole big thing into simple things. Now we have to find some expressions in terms of t. First of all is this guy, and next this guy. So let's just begin our journey. Let's begin with the first one, that is cos to the power 4x plus sine to the power 4x. So what we can do, we can write it like, say, cos square x plus sine square x, their whole square. So this thing minus 2 cos square x sine square x, right? A plus b whole square minus 2ab, and that in terms a square plus b square. So it is 1, and this is nothing but t square. So this thing is 1 minus 2t square. And what will be our this guy, cos to the power 6x plus sine to the power 6x? So if we move our attention to this guy, it is nothing but the cube formula. See, cos square cube x plus sine square cube x, that is a cube plus b cube. What will be the formula? According to the formula, there is a part cos square x plus sine square x, and there is also a part of like this, say cos square x, sorry, there is a square, so cos 4x plus sine 4x, and there is a minus part that includes cos square x sine square x. So if we write this whole thing in terms of t, the cos square x plus sine square x part, it simply becomes 1, and cos 4x plus sine 4x, this part is nothing but 1 minus 2t square. This part is nothing but minus t square. So it becomes 1 minus 3t square, right? So came back to our original equation. Our original equation now looks like this. See, 1 minus 3t square plus there is a term called t into that term. So we have t into 1 minus 2t square plus t cube plus t square, right? So here we can make some adjustments and simplify this whole thing, that is 1 plus t, and t cube is multiplied to this whole thing, 1 minus 3t squared plus t into 1 minus 2t squared plus t cube plus t squared. And now if we make some simplifications of this whole thing, it will simply result as, what will be the result? And let's simplify it then. The simplified result will be something like, say, t cube minus 3 t to the power 5 t cube and t4, so it is t4 minus 2 t to the power 6 plus t to the power 6 plus t to the power 5. So now if we make some further simplification, these two things sums up to minus t to the power 6, and this thing sums up to minus 2t to the power 5. these things sums up to, no, these things are simple. T4 plus T cube, they have nothing to do at all, right? T4 plus T cube, so just make it simple. So we can write it like this: minus T to the power 6 minus 2T5 plus T to the power 4 plus T cube minus T equals to 1, right? We have to solve this equation. See, it is the 6th degree equation. It is quite tough. We are not going to solve it, right? Let's make some tricky thing and tricky substitution. See, we have substituted that T equals to sin x cos x. We can write it as sin 2x by 2, right? Now if we take modulus on both sides, so this value is always less than equals to half, right? So what is the value of this whole thing? If you take modulus on this whole thing, so like just make the calculation. See, these whole things comes up to, see, it is nothing but 1 by 64, it is 1 by 16, it is also 1 by 16, and there is a part of 1 by 8 plus 1 by 2. And if you all make the sum of these little tiny fractions, then you can see the sum is always less than 1, right? The sum will be always less than 1. As the sum is always less than 1, and in right hand side we have this 1, so there is inconsistency, right? This left hand sides always sums up less than 1, and the right hand side is 1. So there is only a simple conclusion that in this case there is no solution at all, right?